Now we're down to the count with the same thing. So be nice to us. I mean, always be nice to each other. But in that same regards, I don't really want to teach all that much today. So I'm hoping to cover the important stuff and then give you guys time to work on the practice. And then I can help you guys with practice problems if you want. Like we can do them up here. But that isn't really meant to be homework. It's just meant to be like, let's get done the next practice assignment. So we're kind of going to work through this problem sort of quickly, and I did not make resource pages for it because I felt like they were a waste when I did this problem with Accelerated 7. The resource pages weren't that important, but if you have a book and you want to open to 715, that would be dandy. You don't probably have to necessarily for today, but here is our problem setup. Actually, can anyone review with me what you guys did yesterday so I can make sure like it wasn't a total bust? Actually, how was this first?
Oh, I like it.
Okay, but was he here before or was he new?
Yeah, he's been here before.
What's his name?
Mr. Peters.
Mr. Peters. So is it Dave? Well, I guess he probably wouldn't
I
tell you
really
his
want
first
to call
name.
one. Like guy that like he's pretty much.
Okay. Supposedly he's going to be here for Mr. Smith today, but don't count on that. Things change, but as of yesterday, he was supposed to be here for Mr. Smith today. So don't get mad if he's not, because subs get pulled and moved and put in different places. But I'm glad you guys like it. So, what was the main gist of solving yesterday? You guys dealt with like fractions, right? Yes, Marvin says kind of slowly. So if we look back at like what your homework was, I mean, even just, or no, the last problem, did you guys make the last problem of the lesson? Did you guys make for this one? So like in the case of 9 halves x equaling 27, what do I do to isolate x and get just 1x? I don't want to have to use cards for this, so if somebody could volunteer, that would be awesome. Ooh, what's that flipped fraction called? The reciprocal. So you can put parentheses on whichever part you want. You can put parentheses on the fraction that you're using to multiply, or you can put parentheses on the part that you had before, and then show that we multiply by the reciprocal. Why? Why do we multiply by the reciprocal? And this should be in your notes from yesterday. Flip back, if you would for me. If it's not in there, please put it in there. Alex?
So the 9 halves continue to a 1.
What's 2 times 9? What's 9 times 2? What's 18 divided by 18? 1. So multiplication by the reciprocal turns your, big word here, coefficient, the number multiplying, so the 9 halves is your coefficient to start. It turns that into a 1 in just one step, which is pretty sweet. All right, let's move on then to try to get through this quickly. So we now have this situation where we're doing some community service and we're out painting apartments. So we have this whole group signed up to come and paint with us, but only 4/7 of that group shows up. So 4/7, awkward fraction, but 4/7 of the group that we had planned shows up. This 4/7 were able to paint 9 apartments. So 4/7 of the group paints all of 9 apartments. We want to know tomorrow when everybody shows up, how many apartments should we expect to be able to get through? So talk with your team for a minute and decide a strategy. I'm going to draw a little picture up here that might help us, but talk with each other and try to decide. If we know 4/7 of our entire student group were able to paint 9 apartments, how can we figure out how much the entire group is going to paint? So try that. 7 of them squared are not the same. Somebody tells you that they're lying. 7 of them squared are the same. It's so not true. Can anyone explain what I've drawn up here? A little box. I drew a bunch of boxes. Bunch of little boxes.
You drew a little fraction
A
guy.
little fraction guy. Okay. Alan?
4 sevens.
4 sevens. Of what? Not of 9. It equals 9. But 4 sevens. They say I drew a little boxy dude, Liam.
How many people in total?
So, if I didn't split up the box, what does this big box represent then? Everyone, the whole student group, right? So, the student volunteers. And I showed 4 sevenths of them showed up. Does that make sense now? Like when we say that whole box. So really now I've got 2 of the student groups if I had the whole thing shaded in. So 4 sevenths is a really awkward fraction. Can anyone tell me a way that you were able to solve this? Like, have you figured out what we would expect when an entire student group shows up? Anyone got a method? Patrick?
I did 9 divided by 4 since there were 4 sevens, and then I figured out what like the there's like a special term for it. I figured out what the unit rate was.
Yeah, kind of like the unit rate if we did 1 of the sevens.
Yeah. And then
What'd you get for that?
2.25.
So then you did what?
And then I multiplied 2.25 by 3, and then added that.
By 3. Why'd you multiply by 3? Oh! You could one step get to your final answer. How many sevens do you want? If we did times 7. So that's one really good method. Now this is not quite the unit rate. We're kind of using that word a little loosely right now. It's our like unit fraction rate, like the 1 of whatever your denominator is. We should think of the name for that. But so Patrick worked it down to 1/7 of the group could paint 2 1/4 apartments. And then he said, well, if I multiply by 7, I can get 7 sevenths. I like your strategy of breaking it down by 4 and multiplying by 7. What if I tell you that I do mine in the opposite order? Do you think we'd get the same answer? So Patrick first divided by 4, and then he decided to multiply by 7. Right? He divided by 4, got 2.25. Now he's going to multiply by 7. Check out this visual, which this is the resource page I decided that we didn't need because I really don't like printing that much paper. So, 4 sevenths, right, of all of this is one entire student volunteer group, painted 9 apartments. Patrick broke it down to the 1/7 first. But what if I multiply by 7 first? I don't know. I'll be able to zoom this out. You'll be able to. If I multiply by 7 first, 2, 3, 4, 5, 6, 7. How many shaded squares do I now have? What's 4 times 7? 28, right? I have 28 shaded squares now. But how many shaded squares do I actually want? How many sevenths does it take to make a whole? 7. So that's why I then have to get to 7 somehow. How do I get to only 7 shaded squares? We divide by 4. And I do Patrick's process in exactly the opposite order. Now, all of that is to really tell you, multiply by the reciprocal. What's the reciprocal of 4 sevenths? Yeah, 7 fourths, right? So if I start with 4 sevenths, I want to multiply by 7 and divide by 4 by doing times 7/4. So in your notes, if you would please, I have no idea if you've drawn all that or not. We had 4/7 of the student group painted 9 apartments. Show the multiplication by the reciprocal on both sides. I'll do it in a minute, but I want you guys to work ahead of me. You're going to flip your fraction, make it 7/4, multiply by that on both sides. That is going to actually turn your left side into 1x. What do I do to my 9 to make the multiplication by 7/4 easier? Yeah, put it over 1. Sorry, I was waiting to see a couple hands come up. But I can put this over 1. I can put anything over 1. I can even put a fraction over 1. And it doesn't change anything. So, we multiply through. Guys, fraction multiplication should not be difficult. You go straight across. Division's hard. Addition, really hard. Subtraction, even worse. But fraction multiplication should not be hard. We just go straight through. So 63 over 4. What's that come out to be? How many 4s fit into 63? 15. What's your remainder? So we would anticipate that tomorrow, when everybody shows up, they could paint 15 3/4 apartments. Does that make sense? And then hopefully, like, come on guys, work a little faster, get that 16th one done. Let's just finish. You wouldn't want to leave an apartment 3/4 of the way from the right? That'd be lame. So if we're talking realistically, oh, you never put down my attendance, but now Ella's here. Thank you. Will you apologize to the secretary and just tell her that I forgot, but now that Ella showed up, we're all here. Thank you, thank you. You're awesome. So next one. Let's have you guys try it on. So I kind of like helped you guys get through this because I wanted to work a little faster. So try this out. Write this in your notes. Write the original 2/3 x is equal to 8. Now, I want to challenge you to do something. I'm going to change the rules a little bit. We don't want to turn it into 1x. Wait, what? We don't want to turn it into 1x. What if I tell you that we want to look at 2x? What if I tell you I want to look at 2x? What should I do on both sides just to turn the coefficient into a whole number? Like if I don't care about only looking at 1x, but I want whole numbers because fractions are kind of annoying. What do I need to do to 2/3 to turn it into just 2? What's another way to say 2/3? 2 something 3. Well, yeah, over, but use a math word. Out of, yeah, but what operation? Division, right? If this is really 2 divided by 3, if I just want to turn it into 2x, I want to get rid of this, right? Yeah. In a way, I'm going to flip to put the 3 on top, but now if I just, so I just want to show you guys another example of what we do, like what happens when we multiply on the 2 sides. So go ahead and write this work in your notes. A 3 on top and a 3 on bottom cancel each other out. They reduce to 1. So this now gives me 2x is equal to, yeah, anyway, 24, right? Now, the reason I show you this, sometimes there's so many numbers involved. There's awkward fractions or there's multiple types of fractions that multiplying by the entire reciprocal, like 3/2, wouldn't work through the whole problem. It like would get really messy. But multiplying by 3 might work for everything, and then later we can deal with the fact that we still have 2x or whatever else. So the multiplication by the reciprocal is not always the easiest option. Sometimes that makes things really complicated, and you're probably going to make a mistake because it gets really tough. So knowing how to multiply by the reciprocal and make 1 is really important. But if all you want to do is get to whole numbers, all you got to do is multiply it by the denominator. Okay? Does that make sense? Are there questions? Should I do this? We're all really awake at 8 a.m. Have I told you guys about college math classes before? Almost every college math class that I took started at 8 a.m. Like that's, yeah, well, it depends on your campus. Our classes at Untitled, they like 8 was the earliest classes because some athletics have practice in the morning. So, yeah, this would be when I would be starting, like, you know, trig or calc 3 or whatever. You do not have to write this down. I want to show you one other method. You do not have, you can write this down if you want. You don't have to. If this was, I don't know, 7x equaled something, what would we do to get rid of the 7? Alex? Yeah, divide on both sides because it is multiplying. Right, so we would divide by 7, and it would be nice, and we'd move on. So over here, that's still multiplication, right? 2/3 of x. Can't I just divide? Eight divided by 2. Divided by 2. Like, what is even divided by a half? Now, if somebody tells you cut that in half, you know what that means. But is that the same as divided by? Ella? Yeah, we can multiply, like multiply by the keep, change, flip method and all that stuff. But I'm just trying to, like, what does this mean? Divided by 2/3. Okay, cut 8 into 2/3 equal pieces and then see how many of them you have. Okay, so let's walk down the road with Grant for a moment. If we had 8 of something, circles might be just as good. If I now I know those third pieces aren't. Wow, that's not very good at all. Now it's better. Slightly better. Okay, I get it. On the floor. Give me another. There we go. There we go. There we go. So we need 8, right?
Yep. Oh, man. One more.
So then what do I do? What do I do then? So we want how many 2/3? I just shade 2 of each of the 3, right? Man, I should have done that to begin with. How many is this going to give me? 16, 2 in each, and there's 8 of them. Does that work, Patrick?
I mean, if you count, if you want to shade on everything, then that right there is just 8. But then getting like the other ones that are not shaded, it's gonna take 2 together. And if that was 8, that's gonna equal. Alright. If you could like shade that with a different color, I can like try to explain it better.
Well, okay, so let's see what the answer actually is. Okay, like what we're trying to work to. We have 2/3 x times, or 2/3 x equals 8. What would we multiply to turn x into 1? We already did this. 3 halves, right? And what did we get? Because 8 times 3 was 24, which then, divided by 2, So I'm going to actually let this question hang. That's a really big question that we don't have to work through right now, and I want you guys to ponder it. What does division by a fraction actually mean? And how could we show it? Then if you want to really challenge yourself, I'm just putting these out here, and then I'm going to really quickly try to get through the rest of the lesson and give you guys homework time. What would a fraction divided by a fraction actually mean? And you can make up whatever problem you want. You can make numbers easier, whatever. So what does a whole number divided by a fraction mean? Now, how can we show it? We know we can keep change flip, multiply by the reciprocal. We know how to do the math. But how could you visualize this? And then fraction divided by fraction is even harder. All right. So real quick, strategies for making integer coefficients, or more so, if we can, making coefficients of 1. We have an item, what's she buying? I forgot what she's buying. Marked off 15%. You come down 15%. What percent do you pay when the item is whole price? What percent do we pay when the item is total price? All of it, right? 100, right? So if it comes 15% off, she's now paying, who can figure out what that means? Marvin? She's paying 85%. Right? You get that if it came 15% off, she now is paying 85%. So this problem goes on to tell us if the amount that she paid was $36.21, that was her sale price. What is the normal price of the item? So the normal price is how much X? I'm trying not to use cards because I know it's Friday and it's early. But what percent was the whole price? 100%, but how many X is that then? Just 1, right? We want 1X. How can I, so please write this in your notes, how can I get that to turn into just 1X? How's the 0.85 attached to the X? Multiplication. How do we undo multiplication? Anybody? Yeah, division. So what do we divide by here? You divide by itself. You want to get rid of this number, you divide by that number. An alternative method. 85 hundredths could reduce 17/20ths, right? I believe. I want to think that's true. If we had the fraction, we'd be dividing by the fraction, but we don't really understand what that means, so we multiply by the reciprocal. This would get us the same thing. Now you don't have to write this down. We are doing the decimal version because we've looked at fractions, we've looked at how to deal with that, but the decimal version is just, well, if you're multiplying by a decimal, divide by that decimal. What do we get here for x? Should be higher than this number. Yeah. 42, and that'd be 60 cents then. Now I get verification. Anyone else get that same thing? Okay, sweet. So if there's multiplication holding it together, we can divide, but if it's multiplication by a fraction, that's pretty tough. And I'm going to let that be it. Use the last 10 minutes. All of these, we would here multiply by 6/5. Here, multiply by 3/5. Here, divide by 0.8. And here, divide by 0.12. So, if you guys want to make requests of homework problems to do, we can start on the homework and use the next 10 minutes to get through some of these together. I'm going to make this bigger. So check out the homework for a second. Tell me what you want to see solved. Yeah, that's sad. Toys R Us is closing all of its stores. They are like $8 billion in debt or something really bad. I think $8 billion is like a hyperbole. I'm making stuff up, but they're really far in debt. And I think Toys R Us owns all of the R Us stores. I think. Don't quote me. And Babies R Us could actually be doing well because everyone has Babies.
But I'm a Toys R Us again.
No, you're not. You already are.
I got great stuff now. Like, it's so true. You make a lot of voice
I mean, it's happening. Whether you like it or not, it's happening. So, does anybody want me to do their homework for them, or are you just going to sit here and waste this time? Oh, you got to request a problem. Patrick. So, have you looked up anything dealing with box plots? You kind of just sold yourself out here, which is okay. But we have worked a little bit, I believe, box plot information has already been in homework problems. Quartile, or if I even just look up quartile, let's do that. That'd be fun. A, B, C, D, F, G, H, I, J, K, L, M, N, P, Q, R, I skipped it. Look, back of the book, this amazing thing where we can look things up. Quartile. Along with the median, quartiles divide a set of data in 4 groups of the same size. Also see box plot. So then it redirects me to page 387. So I go to page 387. Hi, hello, I'm upside down. 387. So if you don't know what we're talking about, go look at 387. Quartiles and interquartile range. It walks you through the entire process. So I will do that homework problem for you, but I had to at least put it in your face that you have the resource to find all of this information. All 7th grade math knowledge is in between the front and back cover of this book. It's a really well set up book. So the first thing we have to do, and probably the most annoying thing, is put the data in order and make sure that we don't miss any of our data points. I lost my pen. You're so good at finding those things that I've lost. So, first, I think we start with 9 being the lowest value. We've got 3 of them. 999, 110, 2 11s. So you should be writing this data out with us probably, unless you feel like doing this problem on your own. A12, I think. A13. I mean, we can play bingo if you guys want. A14. A15. A16. A17. And that's it. So then, and in high school, you'll start to call this a checksum. They will sum the data set and you check that your sum lines up with their sum, and your calculator will do this for you. We check quantity. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have the same quantity of numbers. We're good. Now, your median, and we should all know what median means by now. What's median? Middle. It's that big cement thing. When you're driving down the highway, it's the middle of the road, or it's the middle of your numbers. If I have 12 numbers, what's the middle of 12? No! Check this out. If I take this off, take this off, take this off, take this off, take that 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 off, take that. Crap, it's right here. So, be careful. All because 6 is half of 12, I'm going to come to you, doesn't mean your 6th number is the middle. That's not true. That means there's 6 on both sides of the road, leaving your median, Delaney,
11.5.
as the value right in between them. That is your median, and it is your quartile 2. Quartile 2 means the second fourth, because quartile means fourths. So now we do the same process, just in the bottom half. Right there is our dead middle, and it's 9.5, and that's quartile 1. It's the first fourth of your data. And then right in between those is quartile 3, breaking up your third fourth of your data. So we've now got our data broken up into nice little chunks containing 1/4 of the data in each section. Hence the names quartiles. Now the interquartile range, especially if you go back and look at that, if it would stay standing. Yeah. It's in your book. Interquartile range, distance between quartile 1 and quartile 3. Now, when we make this into a box plot, and I think the book probably shows it to you, we might as well do it for here because it says create a box plot. I just have to get the crap out of the way. If you guys are laughing at me dragging stuff way off the screen. We make a number line, so you'd want like an accurately spaced number line, and mine is not going to be accurate because you guys only have 2 minutes, and I got to get you to create a start on time. And most of you have heard this called a Box-and-Whisker plot, but we don't really say whiskers once we get high up in math. So I start at the end of my whisker out here. I have a whisker, quote unquote, until I reach my quartile 1. At quartile 1 is the edge of my box. At quartile 2 is the middle of my box. At quartile 3 is the end of my box. And at the end of my data set is the end of my whisker. So I start at my lowest point. Q1 is this edge of the box. Q2 is the middle. Q3 is the other edge of the box. And your maximum data point is the end of your whisker. That's all that we got time for. That should totally satisfy that problem. So move on. You have one less thing to do for me. Thank you guys very much. Enjoy Creative Start. I will see some of you later. I'll see a lot of you later.